Good afternoon. So, welcome back, everyone, and we are going to wait here for 5 more minutes. Uh, we would expect more people to join, and then we're going to start. So, wait here for a while. So, we're going to start at 12:35. So, we're going to wait here for 3 more minutes, and then we're going to start. I think the audio quality is fine, right? The volume and the stream quality is also fine, right? Please let me know in the live chat. Good afternoon to all of you. Thank you for the confirmation. So, all right, everyone, let's start. So, we shall start today by discussing having a recap on unit step functions, and we shall talk about unit ramp functions, and then we shall use them to construct piecewise linear aperiodic signals using the unit step and unit ramp signals. So, let's recall what we studied earlier. Again, if you have any query, please post them on the live chat. I will be trying my best to answer your questions. So unit step is expressed as ut. All of you know that. And this is kind of what it looks like, right? So that's my ut, and the value is 1. Right. So this signal, for our intents and purposes, is defined as this. So there are plenty of other definitions that this definition is not entirely correct, but there are plenty of other definitions for unit step function. But for our purposes, we shall be using this definition, where the unit step is a signal which is defined as this. Before time t equal to 0, the value of the signal is 0, and right at t equal to 0, the signal jumps up to 1 and stays at 1 afterwards. So this is how we define unit step. So I think you are all very familiar with this signal, right? So this is nothing difficult at all. So if that is fine, we also let's recap what we so in the earlier class we learned about doing time domain operations on signals. So actually we shall be employing those concepts here today. So whatever we learned in the last class will be quite useful today. And again, this video will be available after the live stream, so you can refer to it anytime you want, and also the handouts will be given to you after the class. So if you have any difficulty understanding anything, please post the questions on the live chat. I'll be trying my best to answer the questions. So now question is same. I already know what ut is, right? So what if I want to plot want to see what ut minus 2 is, right? What if I want to see that? What is ut minus 2 then? Again, that's quite simple. Just a second. Right. So ut minus 2, already I think all of you know that it's a delayed version of ut, and delayed means it's a right shifted version of ut, which got right shifted by 2 seconds, right? So this signal simply looks like this. So it's the same amplitude, so the amplitude stays the same. Again the signal jumps from 0 to 1 in terms of amplitude, but it happens not at time t equal to 0 but at time t equal to 2, right? So that's the delayed version of unit step. So I think this you would be pretty this will be pretty usual scenarios since we discussed time domain signal operations in the last class, right? So with that said, let me ask you this. We have these signals, right? So this is ut and this signal is ut minus 2. What if I want to add these two signals up? So my question to you is this. What would this signal be like? I want ut plus ut minus 2. What would this signal be like? Again, recall that this is ut and this is ut minus 2, right? Let me write it here. So my question is this. Right, so we want to add two signals, right? Specifically these two signals, right? We want to add these two signals very specifically. So let's again draw our axes here. Now here we are actually drawing ut plus ut minus 2. Right? No, it won't be same ut signal, right? So what happens is we are adding these two signals, right? So what happening is this. So try to understand. While time is say, look at this. While time is below 2 seconds, so before t equal to 2 seconds, this so let's start with this. When time is before t equal to 0, right? Let's talk about before t equal to 0. So when time is less than 0 here, before this, both the signals have a value of 0, right? Both the signals have a value of 0. So the sum will also have a value of 0, right? I think that's quite easy to understand, right? So both the signals will have a value of 0 before time t is equal to 0, right? So question is, what would happen at t equal to 0? Look carefully what is happening here. At t equal to 0, what is happening? This ut is jumping from 0 to 1. But this ut minus 2 is staying the same at a value of 0. Yes, what Ovicius wrote here is actually correct. So let's see how that actually works. So when so at t equal to 0, look carefully, at t equal to 0, this signal ut jumps from 0 to 1, but this stays at 0. So if I sum these up, this will put no effect on the signal, right? No effect on the sum because it is staying at 0, right? So let's do the addition, right? So the signal at t equal to 0 takes a jump and goes up to a value of 1, right? I think that's easily understandable, right? So if it wasn't for this one, ut minus 2, the signal would have stayed at t equal to stayed at a value of 1 throughout its lifetime, right? But now look carefully up what happens between time 0 and 2. So this is time 0 and this is time 2. So up until that instance of t equal to 2, this signal has a value of 1 and this signal has a value of 0, right? So up to this point in time, up to t equal to 2, say t equal to 2 is here, up to t equal to 2, what happens? The sum remains at 1, right? So the sum remains at 1 up to t equal to 2. But after t equal to 2, what happens? After t equal to 2, nothing happens to the first signal. It still stays at a magnitude of 1, right? But the magnitude of this signal actually jumps from 0 to 1 at t equal to 2, because this is a right shifted unit step. So this signal jumps from a value of 0 to a value of 1 at t equal to 2. And we are summing up this ut with ut minus 2. So the sum, what will happen to the sum? Obviously, the sum will now, after t equal to 2, the sum will become 2, because this signal has a value of 1, and after t equal to 2, this signal also has a value of 1, right? So yeah, so what happens here? This signal now jumps to a value of 2, and afterwards, after t equal to 2, this signal has a constant value of 1 and this signal also has a constant value of 1. So this sum of these two signals will remain at a value of 2 throughout the rest of its lifetime, right? Right. So let me know if you understand what I just said. Let me know if this is actually understandable. So please let me know if this is understandable, right? So this is ut plus ut minus 2. Right? And what about the rest of you? Right. So let's have another simple question. So my question is, what would this one be like? Ut plus ut minus 1 plus ut minus 2. What would this be like? Can anybody tell? What would this one be like? So I have switched to a graph paper mode in my software. So let me know if this graph paper mode is actually visible to you properly. Okay. So if something obstructs your vision here, let me know. So because I mean doing it on a graph paper, and in fact you will be given graph paper to do this in your exam. So yes. Right. So we are actually plotting this. Yes. So simplest answer is it will be like stairs, because ut is a signal unit step, right? So this for ut, this ut would start. Let me use a different ink. I think this would be nice. So ut would start at t equal to 0, right? Would start at t equal to 0. So this is, my bad, this is ut, right? For example, but we don't just have ut, right? We have ut minus 1 added to this. So since we have ut minus 1, thank you for letting me know. Since we have ut minus 1 associated with it. So now what happens? So say this is time instance 1 second, this is 0 second, and this is 2 seconds. So what happens if this was just ut? This would have been the ultimate plot, right? This would have been everything. But for this signal, we already know that we already have a ut minus 1 added to this, right? So since we have a ut minus 1 added to the signal, of course ut minus 1 is a delayed version of unit step, which basically means this is a unit step that starts at t equal to 1, right? So when this starts up, that signal will also get added up with this one, right? So before t equal to 1, this signal's value is 0, but after t equal to 1, this signal's value is 1. So if you take these two parts, ut plus ut minus 1, this would be just like before, right? Just like before. And so what will happen? The signal, the sum here will jump to a value of 2. And this jump to a value of 2 because we are now adding this portion, right? But the signal will remain like this, will stay like this if it wasn't for ut minus 2. Now we have another part in the signal which is ut minus 2. And ut minus 2 is again a delayed version of a unit step that starts at t equal to 2. And when this starts at t equal to 2, again the magnitude, it gives a magnitude of 1. So that will get added up at t equal to 2, right? And afterwards after t equal to 2, right? So if I add this signal, this will come into effect at t equal to 2, and this will stay in effect after t equal to 2. So its magnitude is again 1, and that will again contribute to the whole sum here. So this is the actual sum of all the signals, right? So of course, understandably, this is a magnitude of 1. This is a magnitude of 1, this is a magnitude of 2, and subsequently that's a magnitude of 3, right? So let me know if this is actually understandable. Let me know if this is understandable. Okay, Manish asked me to repeat it, so let's go back. So Manish, did you understand this one? Let's go back. So this is ut, right? This is ut. So ut is the signal that starts at t equal to 0. So which means at t equal to 0, it jumps from a value of 0 to a value of 1. And this is ut minus 2, okay? And this is ut minus 2, which basically is another unit step that starts at t equal to 2. So basically its value is 0 up until t equal to 2, and then it actually jumps to 1, right? So we are adding these two signals. So when we are adding these two signals, when time is before t equal to 0, both of the signals are 0, right? So the resulting signal is also 0. But after t equal to 0, one of them is 1, another is 0, right? So this is 0, right? So the sum is 1. But after t equal to 2, what happens? This signal is 1, this is also 1. So the sum is 2, right? So same thing happens here. If you look carefully here, what is happening is this signal for this portion, for this signal ut, the value of ut is 1 after t equal to 0. But for value of ut minus 1 is 1 after t equal to 1, and the value of ut minus 2 is 1 after t equal to 2. Right? Right? So with that said, if we just had ut, the result would be a simple unit step like we did earlier, right? Then if you had ut plus ut minus 1, you can understand that we are adding yet another signal to the original composition or original ut. The ut already had a value of 1. Now we are adding another signal. So this portion is basically like the previous example, right? In the previous example we had a ut minus 2, now we have a ut minus 1, right? So this signal has a value of 1 after t equal to 1. So after t equal to 1, this signal will come into effect. This portion ut minus 1 will come into effect, and it will contribute a value of magnitude of 1. So the sum will become 2. But try to understand the fact that the signal ut minus 2 is still 0 up until time reaches t equal to 2. The moment time reaches t equal to 2, this signal, which is ut minus 2, it becomes 1. So it now again contributes to the whole thing, and the whole sum becomes 3. So now after t equal to 2, the sum becomes 3. Right? So let me know. We shall be doing quite a few examples today. So let me know if this is actually understandable. So can I proceed from this? So please let me know if you can follow and I can proceed from this. Right? Okay, so I'm proceeding from this, right? Question. Let me just copy paste this question, and I shall change it a bit. So I just made a copy paste. Right. So now question is, we have this signal, right? Let's add yet another part, but this time a negative part. But let me know. So now we have 3u t minus 3 subtracted from this. We have minus 3u t minus 3, or say t minus 4. Minus 3u t minus 4 subtracted from this. So do let me know what happens here. What do you think happens here? So now we have another part. So let me know what you think. So we are subtracting minus 3 ut. So we are subtracting 3 ut minus 4. So we are subtracting that. So what do you think? So what do you think would happen to this composition here? Yes, Mahesh is absolutely correct. It will actually go again to 0 at t equal to 4 and stay at 0, right? So to understand this, No, 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 no. We are not talking about multiplication here. So what is 3ut? Already know. You already know that, right? What is 3ut? So what is ut minus 4? It's a unit step that starts at t equal to 4. So what is minus 3ut? So it's a unit step that starts at t equal to 4, but instead of jumping to a value of plus 1, it will jump to a value of minus 3, right? And that is added to the whole signal. So what happens at t equal to 4? This happens at t equal to 4. We are actually encountering, try to understand. So this is time t equal to 4. So this is 2, this is time 3, and this is time 4. Okay, this is 3 and this is 4 seconds. So at t equal to 4, this is what we are encountering actually. So at t equal to 4, we are encountering a unit step. So look at this. At t equal to 4, we are encountering a step function that looks like this. So instead of jumping to a value of 1, it will go to a value of minus 3. Yes, after t equal to 4, so this is the signal we just encountered. So this is minus 1, this is minus 1, this is minus 2, this is minus 3. Right. So this is the signal minus 3 ut minus 4. So this one in cyan color, this one is the minus 3 ut minus 4, right? So this is a signal that goes from a value of 0 to a value of minus 3. This value is minus 3, value of minus 3 at t equal to 4, right? And what we are doing, we are actually adding this signal, the one in pink, with the one in cyan, right? This blue one with the pink one, right? We are adding these two signals, right? Right. So I think there won't be any issue. I think you can follow, right? So what happens? So at t equal to 4, this signal, the one in pink is representative of ut plus ut minus 1 plus ut minus 2, will be added to the one in cyan. The cyan portion is this minus 3 ut minus 4, right? This portion. So that will be added to this. So if I add these two signals, what happens? What do I get? So this signal has a value of 3 and this signal has a value of 0 up until time t equal to 4. After time t equal to 4, this signal has a value of minus 3, right? So what will happen? If I add these two signals up, what would happen? Yes, you people kind of guessed right. This signal will go down to 0 and stay at 0 for the rest of its lifetime, right? So yes, the resultant is this new pink one, right? Right. So this is this, and this pink plot here is representative of ut plus ut minus 1 plus ut minus 2 minus 3 ut minus 4. So if let me know if you understood this. So let me know if you understood this. So if somebody couldn't follow, please let me know. Okay, so I'm proceeding further, right? So now with that knowledge at hand, let me ask you another question on this. So we did our yesterday's class, right? We have learned quite a bit of time domain operations, right? So question, can you plot u of minus t? What does u of minus t look like? So this is my question right now. What does u of minus t look like? So can anybody guess? What would u of minus t look like? Okay, yeah, it will be a vertical reflection about the vertical axis, right? It will be a vertical flip, right? Yeah, so of course, if ut starts from t equal to 0 and goes like that, u minus t would be just a flip about the vertical axis. So I think you people are already familiar with the concepts that we discussed in the last class, right? So right, so that would be good autocorrect. Right, so that's u of minus t, right? So I think it's understandable, not that difficult to understand, follow, right? So if you can follow this, let's go into ramp function. Right? All right, so let's talk about so Mitro, we are going to discuss ramp functions right now. Or let's call it unit ramp. Right. So let me again pull back the graph paper. Right. So let's define what we are saying here. Okay. So unit ramp is often written as RT, and this is given, like if you recall our earlier classes, okay, while we actually did do physical classes, right? If we okay, too many smileys, right? When we did do our earlier classes, we did discuss um, Dirac delta function, right? The unit impulse function, which was a derivative of unit step function. Similarly, if we integrate the unit impulse function, a unit step function from 0 to a time of t, and again we are integrating with the dummy variable tau, this is called a unit ramp function. Okay, right? And I don't think it's difficult to understand. So if we define this again, if we just integrate this, what are we going to see doing the integration? Okay, do tell me within these limits, within 0 to t, what is the value of u tau? Again, that's a unit step, right? Which would have a value of 1. So I had a 1 d tau, right? And if I do the integration, that would again result into a tau, and it will jump from 0 to t, and the limit, the result would be t, right? Right. So with that said, ramp functions, or rather unit ramp function, is defined as this. A unit ramp function has a value of 0 before time t equal to 0, and it has a value of t after time t. So let's say this, it will be better for us to understand. Right. So that is how a unit ramp function is defined. Yes, absolutely. So the ramp function is defined as t when t is equal to, ramp function is equal to t when t is greater than 0, and when t is less than 0, it's defined as 0, right? Yes, absolutely. So this can also simply be written as t into ut, right? And you might be familiar with this kind of functions in your by virtue of your circuit theory classes, right? So this is t ut. So a simple t, if I just write t, that would be, okay, so if I just write t, that function would look like this. Hold on, huh? So that's t, right? Right. So that's t. Very simple. Right. So at t equal to, so the signal is basically equal to t. If I just say equal to t, then at t equal to 1, the value of the signal is 1. At t equal to 2, the value of the signal is 2. And at t equal to 0, the value of the signal is 0. At t equal to -1, the value of the signal is -1, and so on and so forth. But RT, or the unit ramp function, is defined as t into ut. So the value of the signal is 0 before t equal to 0, right? So instead of having this, we would have this. Right. So the value of the signal is 0 before t equal to 0, and afterwards it grows with a slope of 1. So this signal has a slope of 1, right? So that's called the unit ramp signal. Again, if I ask you this question, why is a unit step called a unit step? Because its magnitude becomes 1. Similarly, if I ask you this question, why is a unit ramp called a unit ramp? The answer would be simple again. The question is, why is a unit ramp called a unit ramp? The answer is yet again simple, and it's simply the fact that the slope of the signal is equal to 1, right? That's why unit ramp is called a unit ramp. The term unit is used here to make sure that you understand that the slope is equal to 1. That's a unit ramp signal, right? Right. So if you have any query or any confusion, let me know right now. Yeah. So again, go back. Okay. So again, if you go back to our previous discussion, from the concept of unit step, you already know for ut, okay, the signal jumps from a value of 0 to 1. So instead of ut, if I have 3 ut here, the signal will simply jump from a value of 0 to a value of 3, right? So multiplying something here only changes the amplitude of the signal, right? Final amplitude of the signal for unit step. But my question to you now is this. Okay, so with this knowledge, my question is this. Can you make a plot of this? So we know what RT looks like. We want to plot 2RT, right? So can anybody tell me what happens with 2RT? So we are plotting 2RT, right? Do tell me what happens with 2RT. Yes. So for 2RT, the slope will simply be equal to 2, right? So 2RT obviously will be this. 2RT will be 2TUT, right? So simply the result will be, yeah, straight line after t equal to 0 with a slope of 2, right? So if I use a different ink maybe, so of course the value of the signal will be 0 before t equal to 0, right? So before t equal to 0, the value of the signal is 0. And afterwards, the slope of the signal will be equal to 2. So when t is equal to 1, the value of the signal will be 2. When t is equal to 2, the value of the signal will be 4. So on and so forth. So with that said, this is one of the points through which the signal will travel, and so on, right? So you can see at t equal to 1, this signal has a value of 2, right? And this will gradually increase with that same slope, right? So this is 2RT and this is RT. This has a slope of 1, but this has a slope of 2, right? Right. So if let me know this is actually something that you can follow properly. So I think you can follow, right? Please let me know if you cannot follow. So again, feel free to ask me questions. I'll be happy to answer them. Right. So again, I have another question for you. So can you now plot r t minus 1? What would r t minus 1 be like? So can anybody tell me in the live chat what is r t minus t? What is r t minus 1 going to be like? Yeah, exactly the same thing. So we already understand this, right? From our previous classes, from our last class. Yes, it will be just right shifting RT by 1 unit in time, right? 1 second in time. So RT minus 1 is nothing but T minus 1 UT minus 1. So this is nothing but a right shifted version of, so you just right shift RT by 1 second, right? So that is how you get this. So you get this by doing a right shift RT by 1 second, right? Right. Right. So let me just plot this again. So we are here plotting R t minus 1. This is t. Of course, the signal will be 0 up to t equal to 1, and then it will rise with a slope of 1. So it's a unit step. So it's a it rises with a slope of 1. So this is t equal to 1, and the slope is again. So now of course up to t equal to 1, the value of the signal is 0. Now at this point, which is t equal to 2, the signal's value is 1. At t equal to 3, the signal's value is 2, and so on. Yeah, RT was 0. RT was 0, right? Right? RT was 0 for t less than 0, right? Yeah, look carefully here. RT is in fact defined as TUT. Go back, let's go back. RT is defined as TUT. So RT is indeed 0 before t equal to 0, and afterwards this runs with a slope of 1. Right? This is the definition of RT. So some of my, if you are still confused, let me know. This is how we define RT, right? Right. And there is really nothing to be sorry about any of these. And because you are here to ask questions and I'm here to answer your questions, right? So, right. So again, talking about the definition, this can be defined as this. This is considered 0 when t is less than equal to 1. And this is running with a slope of 1. So this is t when t is greater than 1. Right? That is how we define this, right? So with that said, I have another question for you. So I think this is clear, right? To all of you? Right. Right. So actually, I have developed quite a few Python programs to do these things, and I will show you how you can actually run these things on without actually installing anything. Okay. Before the end of this stream, I shall show you how to actually see things by doing simple Python programs. And don't worry if you don't understand Python programming. Okay, it will be pretty simple for anybody to understand. Okay, I will show you on the live stream later on. Okay, how to construct these signals using simple Python programs. Right, and you don't have to install anything for this. Okay, right. So my question now is this. My question is this: do a plotting of plot RT minus RT minus 1. So now we are trying to plot RT minus RT minus 1. So try doing that and let me know. So all of you already know, right, what RT looks like, right? So this is what RT looks like, right? And this is t equal to 1, right? So my question to you is this: what does minus RT minus 1 look like? Okay, Mahesh is correct halfway through. So he says the slope is 1 till t equal to 1. Yes. And what after that? What does happen after that? So we will understand that from this. So this is RT, right? This portion is RT, right? This is RT. Question is, what is minus RT minus 1? Right? So what is RT minus 1? RT minus 1 is a delayed version of RT, right? But what is minus RT minus 1? Again, take that signal and flip it about the horizontal axis, right? That is how you get minus RT minus 1. What is RT minus 1? Shift RT to the right by 1 second. And then what is what is minus RT minus 1? You just flip it about the horizontal axis, right? Right. So what would this one be? Minus RT minus 1. This would look like this. Right. So this signal is minus R T minus 1. Yeah. So this is how I get minus RT minus 1, because RT minus 1 would be like a with a positive slope here, like this one, and we just flip that about the time axis, right? So what is the sum of these? So this is RT and this is minus RT minus 1. So question is, what is the sum of these? So we are adding these two signals, right? So question is, what is the sum of these two signals? So let me make another plot here, because I think drawing this on the same one would be a bad idea. Hold on. So right now we are plotting RT minus. So right now we are plotting RT minus RT minus 1. So we have RT, this one, the one in cyan. No, not really. Yes, yes. Shamama is correct here. Okay. And then we have minus RT minus 1, the pink one here, right? So what is going to be the sum here? So again, look carefully. So before time t equal to 0, both of the signals are 0, right? So I don't care. So both of them are 0. So the resulting signal is also 0 before time t equal to 0, right? So before time t equal to 0, the resulting signal is also 0, right? But between time 0 and 1, RT is there, right? With its slope of 1, right? So if this was only RT, the result would be simply a signal with a positive 1 slope, right? Right? But now try to understand the fact that at t equal to 1, at this point, so at t equal to 1, again, at t equal to 1, what happens? We have this signal, right? So now to understand what is happening at t equal to 1, let's take a point after t equal to 1. So let's take a point at t equal to 2, say. So this is t equal to 2. So at t equal to 2, what is the value of this signal? What is the value of, say, this signal? This is at -1. And at t equal to 2, what is the value of this signal? This is at +2, right? So we're talking about t equal to 2, right? So if I sum these two signals, RT and minus RT minus 1, what is the value of the resulting signal at t equal to 2? So at t equal to 2, RT has a value of +2, but minus RT minus 1 has a value of -1. So if I sum them up, so we understand that the sum of these at t equal to 2, which is this point, at t equal to 2, will have a value of 1, right? Similarly, at t equal to 3, this signal, which is RT, will have a value of +3, and this signal, which is minus RT minus 1, will have a value of -2. So again, at t equal to 3, the signal will have a value of 1. So I believe you can understand the sum of these two signals will simply look like this, right? So this is the sum of these two signals, right? So do let me know if you understand this, or if you are finding it difficult to understand. All right, so I believe this wasn't difficult to understand. So let me ask you another question then. So my question now is this. So you have successfully plotted this, right? I am adding another component. Okay, before I can proceed, let's explain this once more, right? So we are adding RT with minus RT minus 1, right? So we have plotted RT. So this cyan one is RT, and this pink one is minus RT minus 1, right? So we are adding these two signals. So now if this was just RT, the signal will have a slope of 1, and that will be just RT, right? But at t equal to 1, this new portion, which is minus RT minus 1, is appearing here, right? And this portion is specifically, what will happen with this? This will specifically reduce the sum, right? So now with this, what is happening is, see, again, let me just erase this, so actually I can explain this once more for those who didn't understand, right? If this was just RT, hold on. If this was just RT, this will be just a signal with a slope of 1, right? Like that, without any issue, right? But we are subtracting this portion, right? Subtracting this portion, right? Subtracting this. So basically we are adding minus RT minus 1. Now look at any point afterwards. So look at t equal to 2. At t equal to 2, what is the value of RT? That's plus 2. And at t equal to 2, what is the value of minus RT minus 1? That's minus 1. So what is the sum? Plus 2 minus 1. That's equal to 1, right? That's equal to 1. So this signal won't be like this. But at t equal to 2, this signal will have a value of 1, which is this. Similarly, at t equal to 3, rt will have a value of 3, and minus rt minus 1 will have a value of minus 2. So what is the sum? The sum is once again 1. So what is the total resulting signal? Understandably, this is going to be this. Right? So the slope was going with equal plus 1. Now we have encountered a minus 1 slope, and that actually resulted into a slope of 0. Slope 0 means the signal is parallel to the time axis. So the signal is constant, right? Right. So can I proceed from this? No. Slope of 1 till t equal to 1. And after that, slope is 0. Right? Because we are encountering a minus 1 slope at t equal to 1. So the effect of minus rt minus 1 is appearing at t equal to 1, not t equal to 2. Right? So this signal has a slope of 1 here. At t equal to 1, the slope reduces to 0, right? At t equal to 1, because I have a minus 1 slope that appears at t equal to 1, right? So with that said, let me ask you this. So we have actually successfully plotted rt minus 1. So we have successfully plotted this. Let me add another component to this and ask you how you would actually draw this. So I want you to draw this. Now we have a mix up of u and r. So we have step and lamp functions. Right? So can you people figure out this one? Again, for this question, let me just go back and copy paste everything. Let me just erase everything. I don't really care about this. So can anybody tell me what happens here with this one? So I believe we have established that this is this is R t minus R t minus 2, right? Hold on. Let me just t minus 2. Hold on. So we have established that this is this, right? Yes. Yes, you people are correct. Some of you are correct, some of you are partially correct. So let's see. So this is RT minus R t minus 1, right? So with this, let me ask you this. So what would R t minus R t minus 1, t minus 2 look like, right? So this was again RT minus RT minus 1. So the signal had a slope of 1 up until t equal to 1 when this came into effect, and then the slope became 0. So obviously here we would have something like this. The signal will have a slope of 1 up until t equal to 2 when this one appears, when minus RT minus 2 appears, and this will encounter a slope of minus 1. So the sum will become a slope of 0, right? So now we can safely say that so this signal is RT minus RT minus 2, right? This cyan one, right? I don't think there is any confusion. There shouldn't be any confusion, right? Now, so do tell me what this one looks like. Minus 2 ut minus 3. So minus 2 ut minus 3, this one is of course a step function at t equal to 3. So it's a delayed step, right? Right shifted step, right shifted by 3 seconds. And its amplitude is 2, minus 2, right? So again, this one, minus 2 ut minus 3, this one would look like this is 1, this is 2. Right? Right? So this is minus 2 u t minus 3. Okay? Right? So now we are trying to sum up these signals, right? So obviously, if I sum these two signals, I believe those who got up to this point can very easily understand that the sum of these signals can be quickly calculated as this. So we are summing these two signals, right? So again, up to the point of t equal to 3, the resultant will basically follow this cyan one, right? So we would have RT minus 2. So this one, this cyan one, up to t equal to 3, right? Right? Again, so right. Right? And at t equal to 3, we have minus 2 ut minus 3. That takes this rt minus 2 and brings it back to 0, because this signal has an amplitude of minus 2, right? This signal has an amplitude of minus 2. So if you sum these two up, okay, these are the value of plus 2 here and these are the value of minus 2 here. So the signal will go down to a value of 0 at t equal to 3, and it will remain at 0 afterwards, right? So this is the value of 1, this is the value of 2. And so obviously this is RT minus 2 minus 2 UT minus 3. Sorry, yeah, right. So let me know if this is something you can understand properly, right? Right, if you have any confusion, please let me know. So now I have a reverse question for you. So I am drawing a graph and you would have to tell me the underlying functions. So I'm drawing a plot of a certain signal and you'd have to tell me what underlying functions it has, right? So we can proceed with that, right? So same. So now I'm drawing a signal and you'd have to tell me where it came from. Let me just mark all the time instances. So this is time t equal to 0. So this is time t equal to 1. 2, 3, 4. So what the magnitudes? So my question to you is this. Rather, I would say, right. So this is a signal that is given to you, and you have to figure out an expression for this signal in terms of ut and rt. So take 2-3 minutes and let me know. No, Manish, you are not entirely correct. Yeah, your starting is absolutely correct, but the rest is not. Can anybody else shed some light on this? Yeah, the last portion of, I mean, the starting is absolutely correct. The answer Manish gave. Yeah, not entirely, not entirely, not entirely. Shamama is also partially correct. No, Dia is not entirely correct. So all of you do agree that, right? So the signal looks like a unit step, right? Looks like a step. So let me uh, construct the whole same thing again right in front of you, right? And we shall learn how we got there. Problem is none of you are entirely correct. Can anybody post the correct answer before I proceed and actually tell you the correct answer? Yes, Obi is now correct. His combined answer is correct actually. Right. So let's reconstruct the whole thing, okay, and learn. No, Shamama is again slightly incorrect. You wrote RT plus 1. Look at that one. Right. So, what is the first portion of the signal? Let's do that. What is the first portion of the signal? Okay, in a vacuum, if we have nothing, the first portion of the signal looks like this, right? So what is this portion? Obviously, this is the first portion of the signal, right? So what is this portion? That's obviously, so we are actually breaking the signal up into small portions, right? So what is the first portion of the signal? That's u t plus 1. So I think most of you got that right? So this is u t plus 1. That's an advanced ut. So ut with a left shift of 1 second. So that's ut plus 1, right? Okay, Manish, again your answer is partially correct, not entirely. You'll see why, right? And then now at t equal to 1 something is happening, right? What is happening at t equal to 1? It looks like a ramp is appearing at t equal to 1, right? So Shambhu, to tell you what you actually did wrong here, you wrote RT plus 1. RT plus 1 would be a ramp signal which appears at t equal to minus 1. But if it was so, we would have seen some effect of it from t equal to minus 1, but we did not see any effect of any ramp signal from t equal to minus 1. But now we have a ramp signal of, so we have here, look at this portion, between time 0 and 1. This is a ramp of slope 1, right? This is a ramp of slope 1, right? So what do I have? I have a unit step added with a unit ramp at t equal to 0. So at t equal to 0, we have a ramp. And the ramp should have gone forever, right? So now this is the addition of the ramp. So this is plus R T, just RT, right? So the ramp added with a step. Again, instead of the ramp starting from 0, the ramp is starting with a magnitude of 1 and it's going with a slope of 1, right? And why is it starting with a magnitude of 1? Because I had a unit step. The unit step is giving it a +1 value, right? Right. With that said, the ramp only goes as far as up to this point, right? Up to t equal to 1. Then the ramp automatically flattens here. At t equal to 1, the ramp flattens. So the ramp instead becomes a slope 0 at t equal to 1. So at t equal to 1, the ramp becomes a slope 0. How did that happen? Of course, that happened because there was a delayed ramp with a negative slope appearing at t equal to 1. Okay. So at t equal to 1, we have a delayed ramp of negative slope, -1 slope, -1 slope to be exact. That gave it a flattened look here. So now the signal so far would have looked like this. And of course, after this point, the signal abruptly jumps down to 0 and stays at 0. Right? And why does that happen? Of course, because we have a negative unit step at t equal to 2. So at t equal to 2, a unit step appears with a -2 amplitude. Right? So here the signal goes down to 0 and stays at 0 because we have a -2 ut minus 2. So we have redrawn the entire thing, and while doing that, we told you what functions we had in it, right? So again, just to go back and recall what we did earlier, recall these critical signals here. So we have ut plus 1, so we have rt, we have -rt minus 1, and then we have -2 ut minus 2. So this signal appears at, so for example, look at all the individual signals. So this signal appears at t equal to -1, right? So this would correspond to this point, right? So while figuring these things out, you have to figure out all the critical situations where things change, right? Right? So again, we have something happening at t equal to 0, right? So instead of drawing it here, let me just so we are talking about this time instance, right? Similarly, we have rt, which is a ramp that happens at t equal to 0. So of course we had something happening at t equal to 0, right? We had something that happened at t equal to 0, right? Then we have -r. So then we I have this. Hold on. Then we have this portion, which is -rt minus 1. Of course, that corresponds to a point at t equal to +1, right? So of course, this is because something did happen at t equal to +1, something did change at t equal to +1. So this corresponds to this point. And in the end, we have -2 ut minus 2. So this is a signal that takes effect at t equal to +2, right? So again, something did happen at t equal to +2. But nothing did happen at t equal to 3. So we don't have any signal that initiates at t equal to 3. We don't have anything like that. Right? So look at all the critical points where things change and figure the signals out. Right. So if you understood this, I will give you a homework question, and then we will go into Google Colab and do a little bit of Python programming for 10 minutes to show you how you can actually do these things at home. So if this is fine, let me know. So my question to you is this. This is your homework. So do solve this and let me know. So I'm requesting you to plot this. Very similar thing but slightly different. So I want you to plot ut plus 1. So I think you people are still following me, right? I want you to plot ut plus 1 plus rt minus rt minus 1 and then minus 2u t minus 1. So only thing that I've changed here is the last bit. Instead of having minus 2u t minus 2, I have minus 2u t minus 1. So do plot this signal as a homework problem for you. And I will send you the handouts, so don't worry about these. So please let me know if this is fine. Right? You can submit the question. You can email me the answer, right? You can always email me the answer. Okay, right. So let me switch to the screen. Right. So let me show you how you can actually do this on Google Colab. So if you just write Colab, okay, so automatically you would have colab.research.google.com, right? I think you can see this, right? Let me zoom in a bit. So open Google Colab, and if you open Google Colab for the first time, yeah, Shambham, I did get your last the solution you last submitted, and I actually replied you back. So go through that. Okay, this is not the screen that you are going to see if you open Google Colab for the first time. Again, let me go back once more. So just search for Colab on Google. You would see colab.research.google.com. Here actually you can run all sorts of Python programs online, and open this. And if you open this, you would actually encounter this. Okay, so with this you would click on this, a new notebook, and everything that you do on Google Colab would be actually stored in your Google Drive, and it will work like a Google Doc. Okay, Google Doc file, right? The way you use Google Doc, Google Sheet and things. Okay, right. So it's called a Jupyter notebook, and let me rename the file. Say I'm plot signals. Okay, I will share you the file, so you can just go ahead and open the shared files. Okay, so I have to copy a few things, so just wait a while, wait for a second. So wait a while. Right, so copied and copy pasted some code that I wrote earlier. So this actually defines, this my program here defines unit step, unit ramp, unit parabolic function, which is again an integration of unit ramp, and also Dirac delta function. I just defined those earlier. So I just copy pasted the code, and in order to run the code on the cell, let me just full screen this, run the code here, I just have to run do shift enter. Okay, so I will give you all these so that you can actually open the Google Sheet file and do this here. So it is taking a while for the first time, if you're running this for the first time. So it did this, and I'm going to open a few things. So I would say from numpy import linspace, you would see why from I will give you the sheet, this file as a Google Doc file, so you can open this and it will automatically open on Google Colab. Now, let me tell you how you can actually create those signals and plot them on Google Colab here. Okay, I think you people are following me. So the first thing here you have to do is figure out the time span for which you are actually going to plot the signal. Let's go back to our example. Okay, moments ago we did solve this signal, right? Did figure this signal out, right? Right, and we did, for this one we did plot the signal from, say, somewhere before t equal to -1 and went up to t equal to 3, something like that, right? 3 or 4 maybe. So from -2 time t equal to -2 to 4, something like that. So we would actually need to remember that. So once we have figured that out, let me go to this. So we are going to plot our signals from t equal to -2 to 4. So the function is linspace. So we are creating a linear space from t equal to -2 to t equal to 4, and we are plotting 1000 points. Okay, right? I don't think that's difficult to understand, right? And my signal is named x. Okay, and for the previous example, the signal was ut minus 1, ut plus 1. Okay, then we had plus rt, then we had a minus rt minus 1, then we had a minus what was it, minus, hold on, minus rt minus 1, yeah, so we had a minus 2 u t minus 2. So this is that easy. So you have just created x, right? So we have t and we have x. So we have the independent variable and the dependent variable. So time and the signal, right? This is x, the signal, right? So in order to plot this, all you have to do is say plot t comma x. Okay, and I'm just labeling everything. So I'm creating x label and say it is time in seconds, and y label and its amplitude, and let's say make a grid on the signal. So if I now hit shift enter, okay, not 2 ut, 2 star, of course, because I'm multiplying 2, right? It's a programming language, of course, right? So this is a signal that we it did show some weird error. Okay, anyway, don't worry about that. So we now have a plot for the signal that we just did moments ago. So let me know if you can actually follow what we did earlier. Right. So I'll share this file with you, and on Google Colab you can actually just play with this without any issue. So we can change the timing here. So if you want to get a plot from, say for example, t equal to -4 up to t equal to 4, then you can just change this and hit shift enter. It will show you the plot from those time instances. Okay, right. Subsequently, if you want to add up something else, for example, I want to plot from t equal to this to this, and say I want to add up something else, say for example say for example t minus 3, who knows, t minus 3, okay, and then I want to do minus 2 r t minus 5, something like that. Okay, let's create a weird signal and let's plot that up to t equal to 6, say. Okay, so I started plot from t equal to -4 up to t equal to 6, and this is a weird signal we are actually plotting. So let's see how that is what it looks like. Okay, so yes, so with this you can actually do these plots very easily and figure things out very easily. So actually this is good for verifying what you have got, okay, mathematically speaking, right? So please let me know if you understood how to use Google Colab. I will share this file with you. You can change the time span for which you are plotting and change the signal here, and you will get the plot. But for running this, you have to just hit shift enter in each of the cells. So these blocks are called a cell. On each of the cells, you have to just hit shift enter or click on this play button here on each of the cells. And again, you can get in touch with me if you are unable to somehow follow this. Let me know in the live chat if you can follow what I just said about Google Colab. This will appear as a Google Doc file on your Google Drive. So yeah, I'll share this file with you right after the end of this session. So all of you, please let me know if you understood how to use Google Colab to analyze signals. Right, so I'll be staying here for 5 more minutes. So if you have any question, please ask me. I think it went all right today. So if you face any question, please if you have any question, please let me know. So let me know if you have any question, any query regarding anything. And I gave you a homework. I mean, of course, you can do that on Google Colab here. Okay, but I would encourage you to do that manually and then check with Google Colab and check with Python programming here, right? So submit the solution of the homework by mailing it to me. And I will of course let you know about the next class we schedule. So please let me know if you have any query. And thankfully we didn't have any network issues today. All right then, so we are ending the stream right now, and I will send you the handouts, and I will send you the program as a Google Colab notebook, and I would expect you to play around with this thing. And I gave you the problem set earlier. There you would find plenty of examples of signals, and which you can actually do it in a computer, right? And verify with your manual answers. In any case, thank you for being here. I will let you know about the next classes, and stay safe, everyone. So we're ending the stream right now. Thank you very much for being here. So thank you all once again. Bye bye.